Greetings everyone. Today Akash and I will be presenting on a transformative technology that's impacting nearly every aspect of our lives, machine learning in industry and society. We'll explore its fundamentals and dive into how it's shaping industries such as cybersecurity, healthcare, finance, education, and beyond. Let's start with the big picture. Machine learning or ML is a subset of AI that allows computers to learn patterns from data without being explicitly programmed. It's behind recommendation engines like Netflix, real-time fraud detection in banking, and even complex tasks like self-driving cars or diagnosing diseases from scans. Its ability to automate and adapt is revolutionizing decision making.
Fundamentals of machine learning. At the heart of ML, there are three core components: data, algorithm, and models. Data is the fuel. Without good data, even the best algorithms fail. Algorithms process that data to detect patterns, and models are the outcome, the predictive tools that generalize these patterns to the new situation. It's an iterative process where models are constantly improved using feedback. The types of machine learning. There are three main types: supervised learning, where the model learns from the labeled example, like identifying a spam email. Unsupervised learning used to find hidden patterns in unlabeled data, where we have clusters of data, like customer segmentation. Reinforcement learning, where an agent learns by interacting with its environment. Common in robotics and gaming AI. Each has its role depending on the problem at hand.
To successfully implement ML, you follow a workflow. First is data collection, in which you need relevant and high quality data. Second is pre-processing, which is cleaning and transforming data into a usable form. Third is model selection, which is choosing the right algorithm for your task. Fourth is training and evaluation, which is teaching the model and testing its performance. And last but not the least is deployment, which is putting the model into use in a real system. Different problems need different evaluation metrics. For instance, in classification, accuracy isn't enough. You also need to consider precision, recall, and F1 score. For regression, we use metrics like mean squared error. For clustering, we have silhouette scores. The right metrics ensure the model meets your business or research objectives.
Now coming on to the industry applications. Now let's see how ML is impacting various industries from cybersecurity to healthcare, smart cities, and even education. ML is everywhere. We will go through each of these and show real examples of how machine learning adds value to solve critical problems. ML in cybersecurity. In cybersecurity, traditional systems can't keep up with fast evolving threats. ML brings real time detection and response. For example, phishing or malware can be identified using classification model. See, live monitoring frameworks analyze user behavior and logs to detect anomalies. At ACME Corp, implementing ML reduces breach responses by 60%.
However, cybersecurity has its challenges. Adversarial ML involves feeding manipulated input into full models. Concept drift means threat change over time, so constant retaining is needed. And there's always the privacy versus security dilemma. How much data should be monitored?
Anomaly detection in network traffic. Unsupervised algorithms like clustering and PCA are used to detect anomalies in network traffic. By understanding normal patterns, any spike or deviation would signal an intrusion. Visualizing tools help in security analysts spot these quickly.
ML helps both in static analysis, which is code inspection, and dynamic profiling, which is behavioral analysis. But attackers attack quickly using polymorphic and zero-day malware. This raises a question. Can ML keep up?
ML in IoT security. Now, IoT devices are everywhere: smart homes, factories, even hospitals. They are vulnerable due to resource limitations and diversity. ML can detect abnormal patterns in real time, but challenges include power constraints, privacy, and the need for lightweight models.
Intrusion detection systems powered by ML can significantly improve IoT security. They are used unsupervised method for anomaly detection and deep learning for complex traffic analysis. The goal is to detect attacks early and reduce false alarms. ML also supports predictive maintenance. Instead of waiting on a machine to break, sensors feed data into ML models that predict failures. This approach reduces downtime, cut costs, and boosts reliability.
Now, coming on to ML in healthcare. Healthcare is another major area. ML can process massive data sets from EHRs, genomics, and images. It enables prediction and personalization care, like identifying cancer in early stages or tailoring treatment to a patient's DNA. Disease diagnosis and prediction. ML models like CNN analyze X rays and MRIs to detect conditions early. Predictive models flag high risk ICU patients. Hospitals use these, have seen up to 20% fewer ICU deaths, saving lives through early action. Personalized medicine. ML combines genomic, behavioral, and biochemical data to suggest treatments. In one case, ML help optimize chemotherapy plans, improving results by 30%. This kind of personalization care is the future of medicine.
Traditional drug discovery is slow and expensive. MS speeds it up by predicting drug interactions and designing molecules in simulations. This has already shortened timelines for clinical trials significantly. But with great power comes responsibility. If the training data is biased, the outcomes will be too. There's also a gap between what ML can do and what's legally allowed. Plus, when things go wrong, who's accountable? The doctor or the model? ML in banking and finance. Okay, ML is changing how bank operates. Okay, it automates decisions, improves customer service, and detects risk. From spotting fraud to algorithmic trading, ML makes financial services smarter and more efficient.
Fraud detection. ML models analyze transactions in real time to catch suspicious behaviors, often faster than humans. Deep learning and anomaly detection techniques help minimize financial losses. Then comes the credit risk and loan prediction. ML models considers more factors than traditional credit scoring, improving fairness and accuracy. They also streamline loan approvals, making them faster and less biased. Algorithmic trading. In trading, speed is key. Everyone knows. ML identifies market trends and executes trade in milliseconds. It also helps in diversifying portfolio and managing risk behaviors. Better be than humans. ML for smart cities. Smart cities rely on data, and ML helps them make sense of it. It optimizes traffic, energy use, waste collection, and public safety. Ultimately, this leads to cleaner, safer, more efficient urban life.
Traffic management. Real-time data from sensors feed into ML models that optimize traffic lights and railroad signals. This reduces congestion, saves time, and cut emissions. Okay. ML predicts energy uses and manages smart grids to reduce waste. It also helps integrate renewable resources like solar or wind into city infrastructure. ML improves collection and routes and recycling by analyzing sensor data on trash level and times. It helps cities become more sustainable.
Now, coming on to the public safety and surveillance, as you can see from the graph also, ML detects crime patterns, recognizes face in crowds, and help allocate police resources more efficiently, more productively. While powerful, it also raises serious ethical questions around surveillance and privacy. ML in education. Education is becoming more personalized. ML driven platforms adapt in real time to each student's learning style. Predictive analytics can be used to flag students who may need more help before they drop out. AI tutors and assessment tools. Intelligent tutoring system simulate a teacher's interaction. ML also helps in grading essays or codes. However, we need to ensure these tools are fair and culturally inclusive.
Beyond profit, ML has the power to improve lives globally. From responding to disasters to fighting poverty and protecting the environment, ML can be a force for equity if used responsibly. Thus, we introduce ML for social good. Disaster response. ML helps predict and respond to disasters by analyzing geospatial and environmental data. It can guide relief efforts and optimize logistics in real time. Tackling poverty. ML supports microfinance and aid targeting by analyzing satellite and census data. In one project, credit models help reach unbanked communities. raising success by 15%.
Environmental sustainability. It is very crucial. ML detects deforestation, forecast pollution, and help build climate resilience infrastructure. These tools are crucial in our fight against climate change and very detrimental for our future. Then there are the ethical risks, but there are risks. ML can reinforce biases against vulnerable communities, enable surveillance, and operate as a black box. Transparency, fairness, and accountability must be built into these systems from the start. Otherwise, it would be too late to go back on our tracks.
Thank you. That's a wrap up of our talk. Machine learning has immense potential, but it's up to us to use it wisely. We'd love to hear your questions or thoughts. You can also reach out to us by email.
Email.
Thank
Thank
you
you
for
for
listening.
listening
Have
or
a
by
nice
the
day.
comment section. Have a nice day.